Hey everybody, so today we're going to talk about what an aldol condensation reaction is, and it's just a reaction in which an enol or enolate ion will react with a carbonyl. It's going to form a new molecule, and so that's just two larger molecules bonding together, and then through the elimination of a smaller one, through an addition and condensation reaction. This first part is going to be the addition reaction. It's going to form an aldol, and that's just a product with an aldehyde and alcohol functional group. So we'll start in basic conditions using a C aldehyde, and the base we'll have is hydroxide there. So the negative on the oxygen, those electrons will attack an acidic hydrogen, kicking off the electrons to the carbon. So that negative carbon species now is going to be able to undergo resonance to restabilize itself. So the extra electrons on the carbon will form a C double bond C, and then the carbonyl electrons will be kicked off up to the oxygen, forming a negative up there. That's your enolate anion. But we're going to look about how the negatively charged carbon is the attacking species. So there we have that carbonyl, negatively charged carbon is going to attack a carbonyl carbon, a partial positive on another acetaldehyde group, kicking off those electrons to the oxygen above it, and it's going to form almost our product, which, there's that aldehyde. It's going to have a negatively charged oxygen, which can just pick up a hydrogen from a water and be a little bit more stabilized. And so it's going to form our product, which is a 3-hydroxybutanal, and that's your aldol. That's your aldehyde alcohol functional group product. It's also called a beta-hydroxycarbonyl, just in general. This reaction is also going to regenerate our base, though, which is kind of nice. Alright, so continuing on with this aldol condensation, now the condensation step, we're going to have our product from before, which is that 3-hydroxybutanal, and that hydroxide base is what's going to pull off a acidic hydrogen, and that's going to form a negative on that carbon right there, and water is going to form from that hydroxide with a new hydrogen. And the next step from these basic conditions is going to be an E1CB mechanism, but we're going to show that after this resonance right here. So if you notice, it's going to be pretty similar to that from the addition step, in which you have a new C double bond C forming, pushing that carbonyl electron up to form a negative on the oxygen, which is your enolate anion. But we can also form a C double bond C on the other side, which is pretty important because it's going to push off that hydroxy, that OH group, as the leaving group, and that is what the E1CB mechanism is. So whenever that C double bond C forms, pushing off that hydroxy, we're going to be left with our new product, which is a 2-butanal, and then like before, our hydroxide base is going to regenerate as well.